If your business is going very well, you don't want, right? Slightly, but you don't want to change it into the sandwiches chart, right? When your business is so good. So that's the same thing. So the current, actually in terms of the architecture, the relational database model is not the perfect, even worse than other model. Object-oriented database model is better than the relational database model sometimes. So think about your program language and the software engineering. Do you use the relational model? No. Only the object-oriented concept actually govern most of the computer science data structure and software. The only exception is database. Database still use the relational model. That caused the problem of the database programming. So database programming is not straightforward because relational model is different from object-oriented concept. Your programming language is C#, .NET, Java. Most of them are based on object-oriented concept, which means you regard data as an object. What about database? No, it's a relation, which is different from the object. So there are huge gap between data and your program. That caused the problem of the database program. Okay, so we will see such a relational model. So who proposed that idea? Dr. E.F. Cole. Well, 1970 is actually the published date. So he proposed the idea. 1969, when Professor Lee was okay. Then at the time, you can see the large shared database, which means large data. When you have the small amount of the data, so you don't have to use a relational model. You can use just a file system. That's enough. That's faster. Okay. But when you have the very large database, it's a little bit problem at the time. The people. Idea is, it looks like a very simple idea, but it's a totally different concept at the time. Even nowadays, it's a little bit hard to understand the concept. Concept is, why don't we consider data a group of entity, group of data as just one. Consider data as a group. That's the idea. Anything special? No? For example, what is this? What are they? It's a natural number. Okay? So natural number is true. You can change it to order, right? To prove this one, how can you prove it? You need to test all of this. Before that, one update. So that's the different thing. It's the same idea. If you just consider 1, 2, 3, 4 forever, nothing special, right? But if you consider this one as the natural number, usually n, natural number, what does that mean? Actually, you use concept of set. Okay? It's a totally huge difference with this, without this, and with this. There's no way to represent infinite number. How can you define finite number? 1, 2, 3, 4, forever? Using set. That's simple. You consider element as a group. That is a set. That is a natural number. Similarly, you can define a rational number. You can define the real number. Even you can define imaginary number, right? Complex number. With the help of what? Such as set theory. So why don't we adapt to such an idea? Let the one represent one entity, like the student 1, student 2, student 3, student 4. Why don't we regard group of students as a one, that is Actually, it's a set, but Dr. Yef could use a different name because set is the same as the set theory in mathematics. So he used a different, the name of that is a relation. What is a relation? Relation is a group of data. That's it. Group of entity. That is the relation. Okay. What about your program language? What about the other computer science subject? They consider data as data itself. It's called the record. It's just called the attribute. So that is the reason you need to get one by one, process one by one, and represent one by one. Okay? But here, database, consider. Using such a concept, we can handle no matter how many data we have, like the 10 millions of data. It's nothing but one relation, student relation. Okay? So that is the idea of the relational model. So relational model actually does not start from the relationship. Many students actually they're confused. Relational database model means relationship. No, actually it's from concept of relation that is the same as set. Actually when he made the name, it's a relation from the kind of relationship. However, the relation is the same as the set. So we can see the definition of relation as the group of data, group of rows. However, if we consider like the Lee, CS, and the ID 111, this is one element. Another element, the Patel, E, and James, and Amy, and 333. Three elements, but each element has the attribute, right? So this one has the same attribute, same attribute, same attribute. So in different way, we can see such a relation as a group of, is a name, major, and ID. So we can see the relation as also group of columns, group of attributes. So this one, group of the data, 1, 2, 3 data, group of data, group of the row, group of the entity, but also we can view as group of attribute. Why? What is this? It's a table. Spreadsheet. Table. So you can see 1, 2, 3, A, B, C, D, and 1, 2, 3 row number and column name. Same idea. So we can view this spreadsheet as a group of column. Also, we can see group of the row, group of data. It is true. Most of the database system focus on this way, which means we have 10 columns. We have millions of data, mostly. The number of column, number of data, if you compare, this one is much, much bigger. So we'd like to find the specific data quickly. So many of the database system focus on is row-based or tuple-based. Sometimes it's called a tuple in database terminology. Okay? If you search the dictionary, I'm not sure whether tuple is the dictionary word. Always, whenever I type a tuple, Microsoft Word is the red line. So anyway, it's called the tuple, same as the rows. But we have been focused on this way. However, nowadays it's changing. Column-based approach is also very important nowadays. which means we have a lot of columns. Think about sensor. So I have this sensor. It can capture temperature as well as the humidity. So I deploy. I make the 1 millionth of sensor, then deploy the United States. Okay. Every day we collect the data. So how many columns? 1 millionth column. How many data? Once a day. So by grouping the northeast region, like this one, and specific area, it's important. So it's column-based approach. It's also very important nowadays because of the changing the environment. Okay, but mostly not still nowadays the row-based approach. So important. So this is the definition of relation. Quite easy. So formal definition, as I said, formal definition, we use the mathematics. That is the reason it has something, notation, terminology, like we call the relation. We have seen what is the schema. Schema is the description. Anyway, we try to describe the database using certain rule. That is the database model. If we are using ER model, we try to describe the database information using such an entity relationship. So that is a schema, also database. So we are using the relational model. So we try to describe such a database. That is a schema using relation. So that is a relation consists of A1, A2 to AN, the infinite number of attributes. So our goal is to find such a number of attributes that can describe the relation. Okay? So for example, the customer relation, it's not relationship, it's a relation. It's a set, customer set, like the natural number set. So customer relation consists of ID, name, address, and phone number. Okay? You realize if you list all the customer, in each element, each entity consists of customer ID, customer name, address, and phone number. Okay? So that is a relation. Then each attribute is from a domain. What is a domain? Domain is kind of jar. Okay? Bucket, huge bucket. That has, for example, customer ID. I have customer ID bucket. It's a jar. It's a domain. It has all the customer ID on it inside. It can be million, it can be trillion, it can be billion. It's about finite set. It's kind of set. That is domain. Customer name is the same thing. I have a big jar which is called the domain, customer name domain. Okay? Then it has the whole names of all possible names inside. And also address is the same thing, and phone number. Are they infinite? No, it's a finite set of the domain. Then each real data, for example, this one, customer ID and name and address and phone number. We have the 4 different domains, 4 different jars. First pick this customer ID from the first jar, and John Smith from the second jar, and the 101 Main Street from the third address, the domain, and lastly, the phone number. By combining this is the tuple or row or data, or sometimes it's called entity, real data, whatever. Okay, this is the formal definition of the relation. Then you may realize our goal is to, from such an example, we need to define what is the domain and what is the relational schema. This is our goal. Okay? But somebody already realized this is the same as ER model, right? Almost. Actually, that is the reason we select the ER model for conceptual design because it's quite similar. So it's very easy to convert. So this is we can say such a relation. This is the same as later table. If you are familiar with the name of table, student table, you already use such a notation, right? Student table, customer table, instructor table, that is the same as relation. Table is kind of informal way, informal definition. Relation is kind of formal definition. So, which means if you write a technical paper regarding to the database, you'd better use name of relation rather than the table. Okay? But in terms of meaning, it's exactly the same thing. Okay? So that is the relation. Relation is kind of group of row, group of tuple, group of the data. However, such a concept of domain is not used currently. Why? If you
Domains are changing.
Because it's too hard to implement in your computer. How many customer ID? We don't know. It's a finite, too many to keep all the customer ID in your computer system. Even worse, the name, right? You need to keep all possible name, right? It's a finite, but it's too big. Instead, in real life implementation, instead of such a domain, computer system, the DBMS system use data type. Data type, this is 1, 2, 3, 4, 5, 6. 6-digit number. This one, maximum 30 character. And this one, 100 character. Right? It's not exactly same, but easier than domain concept. Okay? Actually, when Dr. EF proposed idea of relation, he used domain, concept of domain. Okay? But nowadays, the most practical implementation, the DBMS system, they use the data type instead of the domain. So you don't have to worry about too much how we can implement the domain such a big jar in your system. You don't have to. But there exists limitedly. There exists the DBMS system that use the concept of domain because it's clearer than the data type. Data type, is there any restriction of that? No, just the 100 character. You can put Professor Lee in your address. Sometimes you need to check in your application program whether this is a valid address or not. Okay? You need additional step to verify the data. However, if you have such a big jar that has the address, you don't have to worry about the verification. That's the difference. Okay? So that is the tuple. Okay? So I already explained about the domain. Okay? So this is the final definition of the relational model. So R represents the name of relation. Informally, it's a table. Okay? Then relation consists of n number, finite number of attributes. How can we make the tuple? Usually capital letter represent the name of a relation. The small letter represent lowercase, represent tuple, data, row. Okay? So one row is the domain. Domain, next domain, and domain. What is this? It's a Cartesian product. Why? Think about it. This is a big jar, right? This is another big jar. Set. And tuple. Tuple is combination of the element, right? How can we represent in mathematics? That is the Cartesian product. How many? So many, because it's a Cartesian product, right? So it is the subset of them. That makes sense. So this one line of the mathematical notation is enough to explain about the relational model. Okay. However, nobody understands when I give the only one, this one. So that is the reason informally I describe and explain about it. But you do better than use if you get a job as a software engineer or some developer, you don't have to worry about too much. But if you are in academia, I think that definitely you should be familiar with such a formal definition and notation. So most of the technical paper use such a formal definition. Then explain what is this, and what is this, and so on. Okay? So this is the definition of the relation that we are going to use in our database system. Example, this is a domain. That's one domain. Let's say this is a ID, and this is a name. Okay, so we are building the relation. Relation is ID, comma, name. At that time, this R is subset of domain S1, that is ID, Cartesian product, domain, the name. Okay, so all possible 0A, 0B, 0C, and 1A, 1B, 1C. Not all of this subset of this one will be relation. Okay? That's the way of defining the relation in relational database model. Okay? So this is one example because 0A, 0B, 1C, 0A, 0B, 1C are subset of this one. So it's a valid relation, valid table. Okay? I know without understanding such a theoretical concept, everybody can use that create the table. If you know, just create table name. Okay? If you want to be just a coding machine. That's the different thing. Whether we need a theoretical approach or just a practical approach. So why do we need this one? Later, when you are query, I submit the query, it's a stuck. It takes a long time. You don't know what happened. Okay? At that time, if you understand such a theoretical approach and why this the relational model is not enough to represent my database, so without understanding such a concept definition, it's hard to explain. Okay, so that is the reason I'd like to introduce not details but briefly about the formal definition. In this case, we have the three tables. So this slide shows the formal terms, terminology, and the informal terminology. Because you are familiar with this part, so it's kind of a comparison table. So table is a relation. Column is the same as attribute, sometimes domain. Originally extract from the domain, but not practically implemented a lot. Row is the same as the tuple, right? And values in column, actually the values in the domain, right? But right now is using the data type, like the character or integer or double integer and the float, something like that. And table definition is the same as schema. So our goal is to find the schema. Then populate the table. Populate table means insert the data or delete the data. That is the same as the extension. And intention means, intention is add the column. Adding column is the same as the intension. Extension is growing up to the row. Okay? The intention is growing up to the column. Like this. Then now you understand what is this. So throughout the semester, I'm using the both of them. Okay, sometimes I use the informal term, sometimes the formal term, but I believe that you can understand. This is an example of the relation, student relation. You can see student has group of attributes. This student can be described as name, social security number, home phone number, address, and so on, and GPA. That makes sense. Also, this student has the full entity, full data. So you can describe 1, 2, 5. You can describe the student by combining 5 students. If I bring the he, 5 students, everybody can realize, oh, they are student, like that. But this student relation has only 5 of them. You can populate, you can insert the data. We will see later. Okay? I think that you can understand the most of this, except this. What are they? It's a null. Or sometimes you see nil, right? What are they? Nothing.
0.
0? No.
Similar to 0.
0.
It's similar to 0 because they are object. You can't put 0.
1, 2, 3. I think that this was the common question in your elementary school. Elementary school? Middle school? So which one is different from others? 1 to 3. One is different from the others.
The third one is different.
The third one is different from the other. This is an empty set. This is an empty set. This is not an empty set. It has the element like this one. Same thing. Null does not mean the 0. This is nothing, empty. Okay? Why we need to consider such a null here? Actually, the Davidson does not have a home phone number. Okay? But if there is no home phone number, doesn't obey the rule, right? Each element, each data should have the same column, same attribute. But this one does not have home phone number.
What does
so
that?
We cannot have Dick Davidson here as a student relation. We need to create a different one. That doesn't make sense, right?
But does that consume memory as well? Does that consume memory as well?
That is one of the drawbacks that we will discuss later. Okay? But simply doesn't exist does not mean no space. You need to do something like the NULA, like the 4 byte for nothing. So that consumes the computer resource. Anyway, before that, this Dick Davidson not a part of this student because it needs name, social security number, and home phone number. So it's not the convenient way. So to represent something virtual data, okay? So it's a NULA, null data. Null does not mean 0, it's not existing, okay? But it requires something computer resource like the memory and hard disk drive. Later we will see. So similarly, for office phone number, you can put the null to make the same format for each attribute. Okay. Several other characteristics. Oh, sorry. That is, it's a 25 kid.
It doesn't work.
Okay, so next class we will cover the last part of the relational model. Then we will see our missing part here. So we learned the ER model, we learned the relational model. We will fill up this gap. Okay, thank you and see you next class.